Hello everyone, I am Anam Ansari, the Vice Captain of Nirmaan Hyperloop, and we are so grateful and to present in this conference. We will be presenting our work on Aeroshell today, and before that, I would like to give a little gist of our team before we begin. Next slide. Our team was founded in 2018, and today we have 60 students from various engineering domains working with us. We are also the first team from Mumbai who aims to build a globally recognizable Hyperloop pod. And we have been constantly working and we have accomplished the prototyping stage of our pod. Now we are looking forward to the manufacturing stage. Next slide. So Pravek is our first pod prototype to be built and its measurements you can see on the screen. Next slide. Now, before further ado, I will hand over the presentation to Ayush Agarwal, who is our team lead, and over to you, Ayush.
Okay, so I will be presenting the aerodynamics domain. I'm Ayush Agarwal. Since our pod is capable to travel at the speed of 150 kmph, there will be a drag induced in the pod. Therefore, the role of aerodynamics domain in our team is to reduce the aerodynamic drag induced in the pod by multiple iteration through simulation software. In doing the design of our pod, the aerodynamic geometry of the pod is generated through a set of Bezier curves, which ensures curvature continuity. The various control points over suction side and pressure side is used to maintain the pod constraints like spacing under the fairing with electronics, batteries, and frame structure. The shell will be an independent body which will be attached to the frame structure using the bolt and nut assembly. Next slide. The dimension of the aerodynamic shell is given on the screen. The length is 2.8 meters, in height 0.57, and in width 0.46. The analytical Before we move to the simulation result, we did the analytical prediction. The Reynolds number are on the screen, and the Mach number was approximately 0.162. Because of this Mach number, we chose density-based solver. Next slide. During the assumption and numerical modeling, we use turbulence model of K omega SST type, and in the vacuum tube we use the adiabatic slip wall, and in the fairing boundary we use the no slip wall condition. And the inlet in the speed of the velocity inlet we consider 200 kmph. Next slide. The further the 2D results are on the screen, the coefficient of drag is 0.13 and the was uh, uh, coefficient of lift was around 0.5. Uh, Next slide. At low Reynolds number, some vortex shedding at low speed during the transition and the acceleration of pod can be observed. In fact, accelerating until the full speed will make the pod pass through all the Reynolds number. Therefore, a transient analysis was also done, and the velocity profile video are on the screen. After finalizing the design after the 2D and transient analysis, the design was inspired by McLaren Speedtail, and we moved to the 3D analysis. And the 3D analysis results are on the screen. For the continuity of the solution, we use multiple iterations. Next slide. The coefficient of drag was 0.12 and the coefficient of lift was 0.1, and the lift force was around 195 newtons and the drag force of around 236 newtons. Next slide. The mass of the pod since we use the material carbon fiber, the mass of the pod aerodynamic shell in terms of fiber was 4.5 kgs, and in mass of resin was 4.5. And in total, the mass of aerodynamic shell is 9 kgs. We maintained the minimum factor of safety 3 in our aerodynamic fairing. Next. A failure prediction, analytical prediction was done on the Aeroshell using a stationary study with ANSYS. The CAD of the shell was imported with mechanical properties typical of carbon fiber and epoxy bidirectional composite, which we'll be using for the manufacturing with a 45045 configuration. And loading condition were assigned as per the CFD simulation results at the speed of 200 kmph. The manufacturing process, in the manufacturing process, we'll be making a negative mold using a CNC routing, and then further we'll lay up carbon fiber with 45045 coordinates before vacuum bagging it. Thank you.
They would like to thank our current partners. Next slide. So thank you for giving us this platform to present our work.
Thank you so much, Nirmaan Hyperloop, for your presentation. Now the floor is open for any questions that you might have for them. You can switch on your video and ask your question by yourself or type it in the chat box and I'll be happy to read it out. Yeah, Jack, please go ahead.
Yeah, I noticed in the 3D simulation, the geometry you guys used, it looked like just an extrusion of the 2D cross section, or an extrusion of the cross section you guys used in the 2D analysis. Did you guys were you guys also planning on doing a 3D analysis on the full contour of your shell?
Sorry. Yeah, we are planning on the full counter as well, but currently we are just done on the linear basis, because since the pod will be traveling straight in the on the track, that is why we just considered the linear conditions currently. And the fairing is the extruded part, yes, but also we have done the trim. We have trimmed down on the sides, but not much, so that the constraints which we have to maintain for the electronics and battery components. So to meet that, we have just done the extrusion and little bit, cut down from the sides.
I hope that answered your question. Yeah, great. Next up, we have a question asking, what was the manufacturing process that was followed for the shell?
So we have used the carbon fiber, and we have used the vacuum bagging process for it. Currently, we are in the manufacturing phase. We haven't done the manufacturing of our fairings, but we have done the risk analysis before the manufacturing phase.
Okay, great. I hope that answers your question, Pujita. Next, yeah, I guess I saw someone with their hand raised. Oh, okay. Yeah, Pujita has a follow-up question asking you, why did you use CNC?
Yeah, we have used the CNC process so that we can maintain a proper dimensions of the fairing shell for the before the vacuum bagging process, by making a negative mold of it.
Okay. Do we have any other questions? Yeah, please go ahead, Sanchit.
Yeah, so very good presentation. I have a few doubts. Like in your 3D simulations, there was no cut given to the Aeroshell. So, like if you, for example, I am considering that you are mounting your entire pod assembly on an I-beam, if I'm not right, if I'm not wrong,
Yeah.
right?
Yes.
Yeah.
We are
So,
pointing out.
yeah. So, in your 3D simulations, there was no cut given, and it gives erroneous results if you don't give a cut to the Aeroshell. So, I suggest you give a cut to it so that the coefficient of drag and the airflow would be different, and the results would be different.
Actually, we have given the cut for the I-beam structure. We have made a rectangular cross section between the fairing. I think it was not visible on the screen during the presentation clearly, but we have given a cut for considering the coefficient of drag and the total drag which will be induced in the pod for the accurate results.